Hi everyone, Unit 8, Antiderivatives and Integrals, Subsection 1, Antiderivatives. Okay, so there's going to be 5 things we're going to be talking about in this particular section. So you're going to be able to find the antiderivative of polynomial functions. You're going to be able to know that the general antiderivative is the sum of the antiderivative part and a constant. We'll get to that right away. You're going to understand how to solve differential equations. You're going to be able to find antiderivatives with the u function. Remember that when way back when we were doing derivatives? Well, we're going to see that again. Okay, and then you're going to be able to see that a family of curves all have the same derivative. So we'll get to that right away. So part 1, basic antiderivatives. So this is where we start to learn the basic rules of these things. Just like derivatives had the rule, the exponent jumped down and decreased by 1, etc., etc. We're going to have something similar to that. So anyways, to start off, we need to recap. We need to find just the basic derivative of these functions. So if we have a quick look here, so y equals x squared, we've been doing this a long time. So y prime equals 2x. Easy enough. Okay, so b, x squared plus 3. So y prime, oh, wait a sec, that's still 2x. And then x squared minus 7, oh, look at that again, still 2x. Okay, now, if we connect all these things, if f prime of x is 2x, then what is f of x? What's the original? Well, if we have a look up here, 2x, 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 the original function was x squared plus 3, x squared minus 7. It was always x squared, f of x equals x squared, but the constant changed every time. So we're going to say plus c, because we don't actually know what the constant was, because as indicated by a, b, and c, the constant was always different. So the x squared part was the same for each. So don't worry, we'll get to more of that. So the original function from which the derivative was obtained is termed antiderivative. The integral or the primitive. They all represent the same thing, and therefore those words are interchangeable. So antiderivative, integral, or primitive. Antidifferentiation is the inverse operation of differentiation. Like the derivative, the antiderivative can be represented in various ways. If y equals f prime of x is the derived function, then y equals capital F of x is the antiderivative. So that's one way of doing it, y equals capital F of x. Okay, remember that any function in the form y equals capital F of x plus c will always have the same derivative. Okay? Because of this, we have to write the constant c after finding the integral. Eventually, we'll be given more information about the original function, which will allow us to solve for c. When this happens, we'll be able to find the one unique original function. Either way, with or without c, we are finding an equation for the antiderivative. Because this equation could really be anything depending on what the x's are, we say that the original function is not quite defined, so the term indefinite integral is used. Definite integrals, on the other hand, are evaluated at certain values of x to give a single number. We don't get to see those till a little bit later. All right. So the antiderivative, or integral, is commonly represented with this symbol, so the elongated s. Okay, so this symbol here. Okay, this is read as the integral of f of x with respect to x. Okay, so there's this dx part here. Sometimes it's there, sometimes it's not. Don't stress over it too much. Okay, so the example, okay, so the integral of 3x squared equals x cubed plus c. Now, at this point, I haven't shown you how to do that yet, but that's next. So, the basic two-part process of finding any antiderivative is, okay, we raise the exponent by 1, and then we multiply the original function by the reciprocal of that new exponent. Okay, it's kind of like dividing by the new exponent, but multiply by the reciprocal is usually a little easier. Okay, we're going to practice this tons, so let's get started. Okay, so find the general antiderivative of f of x equals 1. Okay, well, this one's almost too easy to start with, but yeah, that's okay. Anyways, please understand that there's an x to the 0 here. So we're going to raise the exponent by 1, so that's going to be x to the 1, and then we multiply by the reciprocal of that exponent. Well, the reciprocal of 1 is just 1, so times 1. Oh, wait a sec, well, that's just x. Okay, so the reciprocal of, reciprocal of 1 is 1, so we just get x, and then, of course, plus c. Okay, so there's our answer. Now, we can always check our answer by taking the derivative of this and seeing if we get the original. So if I take the derivative of x plus c, okay, the derivative of x is just 1, and the derivative of a constant is just 0. So this would just be 1, and it works. Okay, so let's try the next one. Find the indefinite integral of x. Okay, so raise the exponent by 1. So right now it's a 1, so raise it by 1, so 2, times the reciprocal of the new exponent. So the reciprocal of 2 is 1/2. So this guy, plus c. So this works out to, and we usually put that half in front. So 1/2 x squared plus c. Okay, again, we can differentiate that just to make sure if we're right. So remember, the 2 comes down, so 2 times 1/2 is just 1. Okay, and then the exponent decreases by 1. So this would just be 2 times 1/2, so that would just be x. Well, which is exactly what it's supposed to be, so we are right. Okay, so find the general antiderivative of that, 2x plus 3. Okay, so this time we're just doing it twice. Okay, so we have 2x, we raise the exponent by 1, so to the 2, times by the 1/2. Okay, that's the reciprocal of the new exponent, plus 3. Okay, there was no variable there, so it's just going to be 3x, because it was 3x to the 0 before, x to the 0, of course, being 1. Okay, so raise the exponent by 1, and then multiply by the reciprocal of 1 is just 1, so we really don't have to worry about that part. Okay, and then plus c. So the half and the 2 then combine, and we just get x squared plus 3x plus c. And there you have that one. Again, taking the derivative of this, we get 2x plus 3, and it works. Awesome. Remember, the derivative of a constant is just 0. Okay. Moving on. Okay, since an antiderivative is doing a derivative backwards, the antiderivative of a sum or difference is the sum or difference of the antiderivatives. Okay, these are those derivative rules from before, and antiderivatives follow the same thing. Okay, so find this guy. So we want f of x is that, so the most general, so we could write capital F of x if we really wanted. Okay, so we got 4x cubed. So that's going to be 4x to the 4th, okay, times the reciprocal of the exponent, so times 1/4, minus 6x cubed times 1/3, plus 11x plus c. Okay, I wrote it really big so you guys could see it better. Now, of course, the 1/4 and the 4 cancel out, so you get x to the 4th. Okay, the negative 6 and the 1/3 reduce to a negative 2x cubed plus 11x plus c. There you go. Now, one thing that's you're going to get used to is you're going to see this a lot, the 4 and the 1/4. If you notice that right away, you don't have to write that. You could have just canceled the 4 and the 1/4 and just written x to the 4th. That'll be handy later on, but give yourself a chance to get used to this first. Okay, so number 5, integrate x squared. Okay, dx, don't worry about the dx part for now. Okay, it just means that we are differentiating with respect to x. So, raise the exponent by 1, multiply by the reciprocal, 1/3, and then plus c. Okay, so this works out to 1/3 x cubed plus c. Okay. Again, if we really want to take the derivative, the 3 comes down. 3 times 1/3 is just 1, x squared. Okay, derivative of c is just nothing, so it's just x squared. Hey, that's what we started with. Perfect. Okay, a few more, and then we'll be done. So the general primitive of that, x cubed. So again, raising the exponent by 1, multiplying by the reciprocal. So 1/4 plus c. So the 1/4 typically comes in front. So 1/4 x to the 4 plus c. Awesome. Okay, there you go. Ooh, what about when there's a square root? Well, we're going to do the same thing we have always done. We're going to change that to a fraction exponent. And the rules don't change for fraction exponents. Okay, we still raise the exponent by 1. Okay, so that's going to be x to the, okay, so plussing 2 halves. Okay, so that's going to be 3 halves. And then we still multiply by the reciprocal. So the reciprocal here is 2/3 plus c. Okay, well, of course, a 2/3 comes in front. 2/3 x to the 3 halves plus c. And there you go. Not a problem. And then the last one, find the antiderivative of that. Okay, so raise the exponent by 1, multiply by the reciprocal, okay, minus, okay, so that's going to be x squared times 1/2 plus 7x plus c. Okay, and then we just do a little bit of rearranging. 2 times 1/3 is just 2/3 x cubed minus 1/2 x squared plus 7x plus c. And there we go. Thanks, guys. Call if you need anything.